winter wheat as a forage system in the southern plains. So for the sake of this presentation, the southern plains would be considered the region encompassing most of Kansas, Oklahoma, and Texas. These three states combined sow about 20 million acres of winter wheat every year. And there's been some previous work that has estimated that from these 20 million acres that are sown every year, as much as about 8 million acres may be grazed. So this really highlights the importance of wheat pastures in this region. Now, reasons why winter wheat can be grazed mostly in this region, and which makes this region unique as compared to other regions in the world, is because temperatures are generally favorable to wheat growth well into winter months. So if we think that wheat has a base temperature of 32 Fahrenheit, and base temperature meaning that that's the temperature below which there's really no growth, and we start to think, well, how many days is our average temperature in this region actually below 32, right? And as we started to answer this question, we start to understand that there can be some growth even during the winter months in this region, which allow us to go ahead and graze the wheat pastures. In fact, anywhere from about 120 to 150 days during the growing season allows for a grazable wheat pasture, so allows us to have cattle on top of the wheat in this region. Now, as far as forage production by the wheat crop, some studies conducted in Kansas and Oklahoma indicate that about 2,000 to 4,000 pounds of dry forage per acre may be produced during the fall, and this means prior to winter dormancy. Obviously, this will depend on several factors. So we're talking about planting date, seeding rate, soil fertility, especially soil pH, as you can see here on the right-hand side on this picture, will play a major role in wheat forage production. And some of these practical aspects I will discuss here in the second portion of the presentation. But here, really, I just wanted to highlight that there are environmental differences, right? So the environment will really dictate how much forage we're going to produce. And these are mostly going to be led by temperature and precipitation during the fall and winter. And so the environment will have a huge impact on the amount of forage produced. There are a variety of differences as well as far as the amount of forage production. Finally, I also wanted to say that not only 2,000 to 4,000 pounds of dry forage can be produced per acre, but also there's a very high quality forage. So, and it's a high quality forage that is being produced during a time of the year whenever other forage sources are low in either quantity or quality. And this time of the year is generally anywhere from starting to graze in about November or December, depending where we are, grazing throughout the winter months, and sometimes as far as early spring. So as grazing is often terminated between mid-February and early March. So when considering wheat forage. So as I was saying, so there's been some previous research done here in southwest Kansas, actually, that has shown that the wheat forage is of premium quality, even when compared with other grass hay, or even when compared with alfalfa, which is considered the queen of the forage here. So whenever we look a little bit deeper into the quality aspects of wheat forage, it often has anywhere from 20 to 30% crude protein, less than 25% acid detergent fibers. As I was saying, generally less than about 25% of acid detergent fibers, and here it's mostly cellulose and lignin. Less than 45% nutrient detergent fibers, which are mostly cell wall components, and as high as about 80% of total digestible nutrients. So wheat forage will decrease with the progress of the crop. So if as the crop moves toward physiological maturity, especially, so if we're past that grazing period on dual purpose systems, the quality will go down, especially fiber content going up and the overall digestibility and protein concentration decreasing. But again, we're talking about dual purpose systems, and so we're actually grazing in a period when wheat quality is really high. with forage quality. Now, many producers may have questions about the effects of grazing on the wheat crop, right? Especially those producers who maybe are now grain-only producers but have considered going to a dual-purpose system, or even those who are now grazing their wheat crop but are also concerned with harvesting grain. So some of the effects that we can talk on of grazing on the wheat crop are first a slight delay in maturity. So as you can see here, often grazing will delay anywhere from 1 to about 4 days in maturity. And although this may seem like not like much, those who have been around the region long enough know how it can get hot towards the end of the wheat crop cycle. So grazing can, to a certain extent, increase high temperature stress during grain field because of this delayed maturity. In other cases, in years, for example, when there's an early freeze, this slight delay in maturity can also be beneficial to yields, just by avoiding the freeze event if that freeze occurs early during the spring. So delaying maturity is one of the consequences of grazing wheat crop. Grazing will also decrease the number of stems, right, or tillers, by two main means here. One of them, cattle removal by grazing itself, but also due to trampling of plants, especially if grazing in moist soil conditions. So let's focus only on the grazing and on the removal of that biomass. This decreased top growth, in years when it can be either beneficial or can be bad for grain yields as well. It's going to depend. So in years when grazing termination is followed by a favorable weather, that decreased biomass can hurt some of the yields, most likely because the weather will have been enough to sustain that excess biomass. So there will be enough spring moisture to sustain wheat grain yields despite the amount of biomass. On the other hand, so that grazing could possibly hurt our wheat yields. Now, on the other hand, if the spring turns out to be really dry, that biomass removal may actually benefit the wheat grain yield as well, because the crop is not going to have that lush development, the lush vegetative growth, which would require an abundant amount of water to be sustained. So some situations when the growing season turns out very harsh during the spring, maybe due to dry conditions or maybe due to spring freeze, wheat yields can benefit from this biomass removal by grazing. So I guess to answer that question, if the wheat yields are going to be affected by grazing, we can look back at some research done by Oklahoma State University's Jeff Edwards and some of his colleagues. So here in this research, they summarize about 20 years of grazing wheat research data from Marshall, which is north central Oklahoma. So this research was done with the variety performance tests, where they're testing several varieties under both grazed or ungrazed systems in neighboring trials here. So in this very first chart that I'm showing you, they summarize data from 1991 until 1998, and both grazed and ungrazed plots were sown in September. So we're actually looking at a little bit earlier than optimal planting date for our grain only here, right? So we're just looking at the effect of grazing. So in this situation, the early planted grazed versus ungrazed wheat, there was an average decrease in about 7% yield, grain yield in high yielding environments. And this aligns really well with what I just said in the last slide here. These were most likely environments with favorable spring weather, during which grazing decreased grain yields. So in their analysis here as well, on the other extreme, there was a slight yield increase in low yielding environments, which again may be due to delayed wheat development, in case these low yielding environments were due to spring freeze, or can also be due to that removal of the excess biomass in case we had drought later during the growing season. Moving on in their research as well, and comparing now the dual purpose system. So the remaining of the data that I'm showing here, we're actually comparing the system which in dual purpose is sown early during September at a seeding density of about 120 pounds per acre, and grazed versus grain only, which was planted in October at a lower seeding rate, about 60 pounds per acre. So the data from 1999 until 2010 really suggests an average yield decrease of 14% associated with the dual-purpose system. So not only the grazing, but actually the system. So considering the previous slide, in which there was about 7% yield decrease due to the grazing only, this data really indicates that about half to a third, or a third to half of the yield losses that are generally associated with the dual-purpose system are caused by grazing, and the remaining proportion of that yield loss is actually associated with an earlier than optimal planting date. So again, this large data set indicating an overall yield penalty of about 14% due to the dual-purpose system itself. Now, one factor that is very crucial and we need to take into account in determining whether wheat recovery potential from grazing during early spring and then for the grain yields as well is the amount of green leaves remaining in the wheat crop at time of grazing termination. So if you take a look at this research here that was also done by Edwards Group, the bottom graph showing us that maintaining about 60% fractional green canopy cover at timing of graze termination or first hollow stem was really crucial to help sustain these yield levels comparable to an ungrazed control. Again, the environmental conditions at grazing termination will affect the recovery of the wheat from grazing. Better recovery will occur under cool and wet conditions. But why is green canopy cover important at grazing termination? So as we think about the green leaves, they're actually the factory, right, that the crop has to produce some carbohydrates and recover from grazing. And it's highly correlated with light interception, water use, or even more specifically the partitioning between evaporation and transpiration, as you can see in the slide. And also the crop leaf area index. So the greater the defoliation that we have at grazing termination, the worse are the chances of full recovery by the crop. So really our main message here is that maintaining adequate green canopy cover at termination is really important when we're considering the grazed wheat crop going for grain. So our conclusions here is that whether grazing will affect wheat grain yield or not, it's really going to depend on several factors, including wheat management, grazing management, soil nutrient status, and also the weather during the spring.